Today, we're solving the problem of Pythagorean theorem. The number one, this is the 2003 AMC 8, problem 21. The area of trapezoid ABCD is 164 centimeters square. The altitude is 8 cm, AB is 10 cm, and CD is 17 cm. What is BC in centimeters? To solve this problem, we need to connect the B. From the B, we do the perpendicular line to the AD. So that's the right triangle. From C, we do the perpendicular line to the D. These two lines, they both the 8 cm. So this we need our property between the two parallel lines. All the height is the same. That means that all the altitude is the same between the two parallel lines. So we use the Pythagorean theorem. Pythagorean theorem is the hypotenuse square, c square, equals the a square plus the b square. From here, we conclude that is the a square equals the c square minus b square. So use this theorem. First, we find I put there is the m and n. So am square equals the 10 square minus 8 square. So 10 square minus 8 square. From the Pythagorean triple, we know 3, 4, 5. That's the Pythagorean triple. So their multiple 6, 8, 10. Their multiple still the Pythagorean triple. So definitely am square equals the 6 square. So we use the calculation. Still we can get 100 minus the 64, still 36. So am equals 6. Same thing, we know the 8 and 17 and also the 15. That's the Pythagorean triple. 8, 15, 17. That's the Pythagorean triple. So we have the one side 17, another side 18. So ND equals the 15. So for the AMC, the contest, calculator not allowed. It's better familiar with the sum, the Pythagorean triple. For the Gauss, calculator allowed. So if you don't know Pythagorean triple, that's fine. But Pythagorean theorem must be the familiar. Now from here, now we got the AM and AD. So the AD equals AM 6 plus the MN, we suppose that's the X, plus 15 ND equals the 21 plus X. Given the area is the 164, trapezoid area equals the base 1, X, plus base 2, AD, is the 21 plus X. Base 1 plus base 2 times height. Height is 8 divided by 2. So trapezoid area is the basic, the plane, the figure, the area. Formula is the base 1 plus base 2 times height divided by 2. That's the trapezoid area. So use this one, we solve the equation. That will be the 328 equals the 16x plus 168. So we have the 16x equals the 160. X equals the 10. X equals 10, that's the B. So the answer is the B. Number 2, this is 2003 AMC 10B, problem 6. Many television screens are rectangles that are measured by the length of their diagonals. The ratio of the horizontal length to the height is a standard television screen is the 4:3. The horizontal length of the 27-inch television screen is closest to which of the following? Now let's us draw the rectangle and the diagonal. That's from the here to here. That's the diagonal. So according to the problem, the horizontal length of a 27-inch television screen. 27-inch television screen, that's here, 27. So the problem asks the length, I use the A here. So to solve the A, we can use the ratio of horizontal to the height in the standard television. If I put here is the B, A to B, that's the 4:3. So according to the Pythagorean triple, this is the Pythagorean triple 3, 4, 5. So the ratio of this one is the 3, 4, 5. Now they ask the 4 to 5, this part. So A to 27. So we use the A to 27, same ratio as the 4 to 5. That's the ratio equation. 4 to 5, that's the B to the C. So we can do this one is the B to A to C for this problem. And so to solve the ratio equation, we use the inside term times inside term, outside term times outside term. That means the 5A equals 27 times 4. That is 108. 5A equals 108. To isolate A, equation both sides divided by 5. So give us A equals the 21.0. That's the 6th answer is the D. 21.5 is closest to the 21.6. Answer is the D. Number 3, this is the 2004 AMC 8 problem 25. Two 4x4 squares intersect at right angles. Bisect their intersecting the sides. So, very important, they told us that they are bisecting their intersecting sides, as shown. The circle's diameter is the segment between the 2 points of intersection. The 2 points of intersection, that's the diameter. So bisect, this is the half of the side. Half of the side is the 2 because side length is the 4. Bisect the intersect side, that means this is the 2. And also, the circle's diameter is the segment between the 2 points of intersection. What is the area of the shaded region? Created by removing circles from the squares. So for this one, we need the, if we continue do that one, that will have this one. So that's the original, the square to the overlapping together. So to find the shaded area, we use the total area and then minus the total area minus the white part, that's the shaded. But first, we need to find what's the total area because they have the overlapping. Overlapping part, that's the square. The square side length, that's the 2 because the bisect the side length. So the square area is the 2 times 2 is the 4. So that's this. I put the A, B, C, D. So the square area A, B, C, D equals 2 times 2. That's the 4. That's the overlapping, 2 square overlapping part. The total area is the 4 square. I have the 2 times 2. So that's the 32. Total, the 2 square, the area, minus overlapping part, that's the 4, equal to the 28. So all the area, the total, the shape area is the 28. But we need minus the circle part. They only ask shaded. The circle, the diameter equals the AD square plus the DC square, Pythagorean theorem. So that's the 2 square plus the 2 square. That's the 4 plus 4, 8. So D equals square root of 8. And the radius equals the D over 2. That's the 2 root 8. So the area of the circle equals the pi r square. So area of the circle equal to the pi r square equals pi times, so root 8 over 2, that's the 4, 8. So cancel the 4 of the numerator and the denominator equals the 2 pi. Shaded area equals total area, that's the 28, minus white part, circle area, so that's the 28 minus 2 pi. So the answer is the D. Number 4, this is 2004 AMC 10B, problem 8. Minneapolis-St. Paul International Airport is 8 miles southwest of downtown St. Paul and 10 miles southeast of downtown Minneapolis. Which of the following is closest to the number of miles between downtown St. Paul and Minneapolis? I use the A to this is the airport. A, that means the airport. So that's from the airport, 8 miles southwest in the map. North is the up, south is the down, west is the left, and the right is the east. So they tell us that's the southwest 45 degree from here. So that's the southwest, that's the St. Paul. I use the P. This is the 8 miles away, and also 10 miles southeast of downtown. So the southeast, we go the 45 degree between the south and the east. So that is the downtown Minneapolis. So I use the M. So now this is the right triangle because this is the 45 degree and another side is still 45 degree. So this is right angle. So here is the 10 miles. The question is to find the PM. So to find the PM, we use Pythagorean theorem. So that's the 8 square plus 10 square. That's the 164. 164, we need to find the closest to the which of the following. We know AMC test, calculator not allowed. So if we familiar with this square, so 13 square, that's the 169, and 14 square, that's the 196. 15 square is the 225. So the 13 square is closest to the 164. So the answer is the A. Problem 5. This is 2005 AMC 8, problem 7. Bill walks 1/2 mile south, then 3/4 mile east, and finally 1/2 mile south. How many miles is he in a direct line from his starting point? So we already know on the map the direction is up is the north, down is the south, forward is the east, and backward is the west. So first, the Bill walks 1/2 mile south. So south is the downward, that's the 1/2 mile. And then 3/4 mile east. 3/4. That's the 3/4, the east. And then finally half mile south, and then another half mile south. So that's the bill from the A to the C. Okay. Now the question is, how many miles is he in a direct line? We connect the AC, and then the build will walk in the direct line. To solve this problem, we extended A, if this is the extended this line, and also we do perpendicular to another line. Now the new shape is the right triangle. What's the total length? If I put it here, the D, what's the AD? Sorry, I put it D. The AD is this half plus this half. AD total is the 1. And what's the BC? BC is the 3/4. This equal to the line he walked to the east. So now the AC is easy. We use the Pythagorean theorem. AC, that's the hypotenuse, equals the 1 square plus the 3/4 square. That is square roots of the 1 plus the 9/16. That's the 25/16. So square roots, that's the 5/4. So 5/4 is the 1 and a quarter. So the answer is the B. Number 6. This is 2005 AMC 8, number 19. What is the perimeter of trapezoid ABCD? Now I copy the shape of this one. And then from the C, we do the perpendicular line. We draw the perpendicular line to the D. So this, I put the F here. Now they ask a perimeter. We need to find the base 2. So use the Pythagorean theorem. AE equals the square root of the 30 square minus 24 square. So 30 square minus the 24 square, that's the square root of the 324. That's the 18. And also FD, still Pythagorean theorem, equals the 25 square minus 24 square. That's the 49 equals the 7. And then the perimeter equals 30 plus 18 plus 50. EF is the 50, that's the 18. 7. Plus 7. 19 plus 25 plus 50 equal to the total 180. So the answer is the A. Actually, for this one, we still can use the Pythagorean triple. First, 3, 4, 5 is the Pythagorean triple. So all the 3 times 6, that's the 30, 24, 18. So the missing part is the 18. For the 24, 25, that's the 7. 7, 24, 25, another the Pythagorean triple. If you're familiar with this one, that will be easy to get this one. That's the 7. Number 7, this is 2011 AMC 8, problem 16. Let A be the area of the triangle with side lengths 25 and 25 and 30. Let B the area of the triangle with side lengths of the lengths 25, 25, and 40. What is the relationship between A and B? So this problem, we have the triangle. Let me draw the two triangle. Now I draw the two triangle. Left side is triangle A. Right side is the triangle B. So they told us the triangle A with the side lengths 25, 25, and 30. So this is the 25, 25, and 30. Triangle B is the 25, 25, and 40. 25 and 25, 40. So they ask the area of the relationship of A and B from the triangle A. From the top we draw the perpendicular line to the base. This is the isosceles triangle. We know isosceles triangle has the property that from the apex A, from the top vertex, draw the perpendicular line. This is altitude. That is the median. And also the angle bisector. So in this problem, we use this one, altitude, also the median. Altitude is also the median. That means the left side is the 15, right side is the 15. The B, we draw the altitude 2, and the left side is the 20, right side is the 20. This is the property also applied to the equilateral triangle. If you draw the altitude of the equilateral triangle, this line also be the median and the angle bisector. So with this one, we know actually use the Pythagorean triple. We can easily get that's the 3, 4, 5 triangle. That's the 20. We use the 3, 2, 4, 3, 4, and 5 triangle. So this is the 25. That's the 20. So this one is the 15. So Pythagorean triple. Same thing for this one. This also the Pythagorean triple. That's the 25 and 20. So we are missing the 15. So that means the height is the 15. We use the Pythagorean triple 3, 2, 4, 2, 5. Also, if you are not familiar with the Pythagorean triple, if you don't know, don't worry about that. We do the first one, the A, we put this, the M. So, AM equal to square root 25 square minus 15 square. That's equal to the 20 square. That's the 20 square. So that's the 20. For the ABN equal to the square root of the 25 square minus 20 square equal to the 15 square. That's the 225. So BN equals 15. So the area of the A area equal to 1 over 2 base, that's the 30, times height, that's the 20. Total will be the 300. For the area of the B equal to base 1 over 2 times base is the 40, height is the 15. We cancel the 2, still the 300. So the both area is the 300. So they are equal. The answer is the C.